to have Pratima here, who is a data engineer at Square, and she has her PhD in computational chemistry from UC Berkeley. She was a mentor and volunteer for practical last year for Y Labs, and this year helping the Square team as well. Yeah.
Thank you. Hi everyone. So this talk is divided into two parts. I'm going to start with some of the machine learning work that my team has done at Square. And so I'm just going to talk about that for about 15-20 minutes, and then the rest of it is just going to be Q&A. I believe that there was a Google Doc for pretty good questions, and so I'm happy to take some time to answer that. All right, let's get started. So, like the title says, this talk is about using machine learning for marketing campaigns. And we do this like weekly and more often, and at a similar frequency at Square, because we want people to join our Square ecosystem. So, like Diane said, this is a little background about me. I studied computational chemistry at UC Berkeley, and I graduated in December 2019, after which I decided I'm going to take a month to recover and then find jobs, which was not the smartest decision. It was really tough to find jobs in March 2020, and so if you have questions about how I spent my time then, feel free to ask me that later. I know that the economy is not doing the best now as well. But after some searching, I started working at Giant, which is a small healthcare startup based in San Francisco. I was on the data science team and worked there for a year and a half doing all sorts of like data analysis, reporting, data engineering, and some machine learning work as well. And then I transitioned to doing much more machine learning full-time at Square since February of last year. All right, okay, so a little more about Square if you haven't heard of it. It is a financial services company, and we work to economically empower businesses. I'm sure if you've been to a farmer's market stand or some of the restaurants around, you've seen a Square terminal for your payment. We have a lot of different machine learning techniques or problems that we solve at Square. These are some examples. So we take a lot of payments. We want to make sure that they're not fraudulent, that the person who's paying is not doing a fraudulent activity, the person who's taking the payment is not doing a fraudulent activity. So that's a machine learning problem. We have a lot of sellers who've signed up to our ecosystem, but maybe we're going to lose them to some other payments processing company. So can we predict who's going to churn or not? And then more pertinent to this talk, how do we get new sellers? We want to keep growing our ecosystem. We want to keep helping all the new businesses out there. How do we grow our company by acquiring new sellers? That's machine learning. We also do data science, which is its own separate track. And so if you are a seller, what has your journey been like? Have you enjoyed our product? Have you signed on to do different things? Are you using different types of products? Revenue forecasting. If you've just signed up, we want to know how much money you're gonna expect to process in the coming year. How much profit are we gonna make out of it? How much impact is it going to have on our business and on the seller's business? And measuring, and again, pertinent to this talk, if we do different types of marketing campaigns to get sellers to join, what are the effects? How are we measuring our efficacy? So lots of different stuff happening, and I'm sure in your classes you've learned about one or other of these problems in industry. It's just, you'll find these things happening at many companies across different industries. All right, okay, so dialing a little bit down into marketing. So there are two different types of marketing, generally techniques. One of them is online marketing. So this is the ads you see when you're browsing, or you're on Instagram, or you're you're using. I'm a little old, but if you're using Snapchat, any of those things. So one of the biggest pro of this technique is that it's cheap and it's a lot. It has a far and wide reach. But then one of the cons is that some of the cons are that there are privacy issues, right? On the internet, you keep hearing about, antitrust, all of these things. So there's data privacy, and then everything here happens on third-party websites. So we are not in charge of Google Ads. We don't run Google Ads, and so we don't have full visibility to what's happening. There is another marketing tactic, which is offline marketing. And this is something like direct mail, like paper mail you see in your actual mailbox at home, sales calls, business cards, flyers. This gives you a lot more control over who you're showing this piece of marketing to, but it's also more expensive and more time consuming to do it. So both of these are somewhat like different ends of the spectrum, and there are different challenges involved in both these techniques. And at Square, we build different machine learning solutions to optimize for these different types of channels. So I'm purposely not getting too much into the specifics, but to give you an idea of what kind of problems we solve in order to optimize these marketing campaigns. A very common problem is predicting who will convert to your business. So I'm sure you've seen in different classes like click-through rate or conversion rate, prediction of something like that. So this is a binary classification model, and we build different types of these based on internal and external data in order to make these predictions. Another type of model, another family is predicting who will convert only when they are marketed to. So this is belongs to a causal inference family of models. So you are actually doing something and you're trying to predict the effect of that action on the group that you're taking. So we build these models as well, especially when we have much more control over who we're marketing to, so we know who has been treated with this effect versus not. And then a last big category for us is predicting who will generate revenue for your business, or how much, actually, this should not be who, or not just who, but who will generate value, but how much value will they generate? So this is a regression problem, right? Like, you want to know that someone who has a huge restaurant, how much value are they going to bring? Is it worth spending all your marketing dollars on this person because they're going to make a lot more profit on you versus like a small farmer's market boutique candle store? Maybe it's only on weekends for some part of the year, there's seasonality, and you want to know what the effects are of marketing to both of those. We want to cater to everybody. How do we understand what impact they're going to have on our business? So, like the slide says, we do all of these and we mix and match all the model predictions in order to optimize the return on investment for our marketing campaigns at the company. This is a slide I just stole from the internet, but I think it has a good overview of a lot of different data sources as well as solutions, and we use this is just like an informational slide, but I think it gives you an understanding of what's not just happening at Square, but what can happen in marketing across the industry. And so, let me see. So you have first-party information, right? If you are an e-commerce business or a payments processing business, you know what sellers are doing on your platform. What kind of business are they running? Are they checking out different things on the website? And so we can use this and we can build machine learning models in order to predict what kind of seller journey they will have, or analyze the seller journey to understand if they will use product A or product B. If product B is more valuable, maybe we want to push that to them if they have a high chance of converting to that product. And then we have a website on the internet with a lot of web browsing behavior. We can use all of that in order to understand how that plays into somebody's behavior or conversion into our platform. Suppose you're a restaurant and you're on the restaurant vertical page on our website. We know that you have a higher intent of converting to that specific product, so we want to show you ads for that specific product. And then when we have all this information, we can build machine learning models, but then we also use tools like Google or Facebook for online marketing, and we have something like lookalike audiences, so we give them our best guess of what's going to work, and then they take that and they find similar audiences and they amplify and blast it out, and then we hope for the best. And maybe this leads right into the next part, which is we hope for the best, but we also then actually measure the impact to understand, did we do well? Did we come up with the best solution? Are we making the most of our marketing dollars? Are we bringing the most value to the company? And so this slide is more about data science. And so data scientists at the company will measure impact in different customer segments. They will help us decide how to set up A/B tests. So there's a control and a test, and I've given here some examples of what can be control or what can be a test. So either a control can be, we never show you anything related to Square marketing. And then a test is that we're showing you an ad campaign on like a website that you're visiting. But it can also be, we show you one version of an ad versus another. Maybe someone is associating with like some message more than another, and one of those ads is successful. Or we have an old machine learning model and we've improved it, and we're now testing a new machine learning model. And in our offline performance, it has been doing great, but we want to test it online. Does it actually work in the real world or not? And all of these are different type of A/B tests that we continuously run to evaluate how we're doing and to make sure that we're spending optimally. An open question right now is what if someone when you're performing A/B tests, what if someone on one of the channels is in the control group, but in another channel is in a test group? And so you can maybe say, like, I will never see online ads through Google Ads, but I will always see online ads in Instagram because I'm in the control group. What happens then? Is the machine learning model working? What's happening here? And so we are working and to use like marketing attribution strategies, which is a whole other class of machine learning, to understand, what happens when you're shown different ads or you're in different groups for different ads. How does that affect you? And so that's another exciting thing that we continue to invest and work on. So this is a result, which is basically through all of this work, our team at Square helps generate more than $100 million in profits from our marketing efforts, and so we're doing good work that has an actual real impact on the company's bottom line, and so that's great on a bigger level, but on a lower level, the technical work involves continuous maintenance and improvement of machine learning models. Like, we want to make sure that they're not getting old, they're not getting stale, the data is current, all the metrics are the same as we want them to be. And so we monitor our online performance throughout the year to make sure that we're doing well. And if we see any dips, Then we work on building new models or retraining models or improving the current models. And how do we do that? Of course, by measuring the effects of using these ML strategies and designing experiments to make sure that we have a handle on how machine learning is helping supplement marketing campaigns. And then, like I said, we have some measure of how different marketing channels affect a specific seller's conversion to Square or journey with Square, but we continue to invest in here because we want to know, like if Facebook is doing much better at marketing to people than Snapchat, then we want to spend much more money on Facebook than Snapchat. How do we know this? How do we do this in a data-driven way? We use our model, we use our A/B test results, and then we also use marketing attribution to understand how do we go forward from here. So there's like the result of all of this work is you help the company decide how we're gonna pave the way forward and invest in the most sound manner. So with that, that's the end of my talk. At least my prepared talk, and now I'm happy to take any questions about this work or any of the questions from the Google Talk. Thanks.
We'll take a few questions regarding the talk, and I have a list of questions. Hope everything works a bit today. That students shared our shared Google Doc that us will answer. Is your question related to the talk?
Hi, this is an interesting presentation, and I'm really interested in doing the machine learning in marketing area. But I have a little question, and you can correct me if I know something that is not the true things. It is that, like, in my understanding, the marketing, that even if you use the machine learning method to do the marketing, you need to know a lot of like cultural background behind the industry or behind the whole society. Because we get some results and we say some factors are influencing this whole thing, and we need to also know that what is happening at this period and what kind of event that happening together that can have strengthen the impact for this event. So I'm wondering, as an international student, I don't know too much about the American society. So we are going to find jobs in 6 months. So do you think this period we can prepare? How can we prepare us for the enough knowledge to let us to like the machine learning model to this event and can analyze any event with it? Am I clear?
Yeah. Thank you for the question. And if people didn't hear, it's just to understand, how other trends that are not in the model data may affect the model's performance, and how, as students, you can, especially if you're international, prepare to learn what's happening otherwise. I would say honestly, so we are the machine learning team, but there are actual there are marketers at the company who know much more of the background, and so we rely on them. But then the second way I would say is especially if you're preparing, I would take data sets that were affected by some event like COVID or something, and maybe like what this data set is, you can find on Kaggle, like I'm sure you can search for those things, and then try to understand how those anomalies show up in the data or how the data is affected by real world events that are happening, and that will give you a sense of how to talk about it. I don't know that there is like deep cultural knowledge that you need in order to do data-driven marketing. I think you need to work with people who have that deep cultural knowledge and bring your data expertise to help them make their decisions better.
Thank you. So it is not about like reading more industry reports. It is about like understanding the data better with your team.
Yeah, it's much more like how is the data guiding us to make decisions, and can we see the events of certain, is there seasonality somewhere? How does the data tell you that, and then how do you account for it? Like I would learn more about how to handle data where there is anomalous or not anomalous even, but these like trends happening in the background.
Yeah, thank you. Sorry, I have one more question. Is that like what is your output? Is it like a final report or weekly report telling them what you found in each data and analyze the methods behind it, or it's just a model with the result?
So I work in machine learning, so for me it's much more models. It's like these are the people who we should market to. These are the people who we should advertise to. And then the data scientist counterparts of the company will then measure, did it actually work? What is the impact?
That is very clear, thank you.
Thanks.
Thank you for the talk. I'm really interested in the side of machine learning as well as the marketing side. One thing I'm working on right now with my internship is retention and like understanding how to define retention. So it's curious if you're using machine learning to define retention for share and what that looks like and how you're building the model to do that.
Yeah, so the talk is about the question is about us building machine learning models for retention. And so my direct team doesn't do this, but I know that we do have retention models in order to understand, who is gonna leave. Like, should we try to contact them and ask them what's happening? And I think in order to do this, you need to, again, like come up with, I keep saying data-driven, but a more data-driven way of labeling who is gonna leave versus not, and then building machine learning, some sort of like time series-based machine learning models in order to make those predictions. And so firstly identify, and your label definition is not gonna identify everybody, but how do you identify most of the people who are looking historically who have left? What is the start of their leaving? Like, is it like, oh, you stopped interacting or opening this app for 7 days or 50 days or 3 hours? Like, what does that mean? And then once you identify that as your label, then you find features that can help predict that label, and then you build a machine learning model and try to test it out and see how it goes.
That's exactly what I'm trying to do right now. Actually, like we don't know what like a good customer is. Like we don't know what the acquisition is. So like is that something that is like an iterative process for you, where you can figure out what is a good customer?
So like I said, my direct team doesn't build the retention model. I would imagine that it's a question. It's also you're working at a company, right? You can talk to your stakeholders who are like the people who are maybe reaching out to customers who are going to churn, and ask them like, do you know, like you have subject matter expertise. Who are good customers? Like, sure, I can try to look at the data, but if you give me useful things. Of what, like, had they asked like help questions like had issues with logging in the past or something like this, right? Like you see this much more, and that will sort of maybe give you an understanding of where to start digging in order to get that label. Like ask the people who are most familiar with, who are maybe not machine learning people, but who are most familiar with customers leaving the company or staying at the company. Yeah.
My last one was just so you think of work to try to machine learning to.
Oh, definitely. Yeah. I mean, like, ostensibly, so is it worth using machine learning for retention-based modeling? Ostensibly, everyone is leaving your company and you should be reaching out to everyone proactively. That's way too much work and way too much time. And so you want to identify the people who are most likely to leave so that you can target, you can use your company's time the best and also make those dissatisfied users' experience that much better by taking the time to understand what's happening. So yeah.
Thanks for the talk. So I was wondering what you have found to be the most common sort of user journey or journeys that lead to successful conversion in your case, whether it's from a certain, like if it's paper advertising like on a bus stop or something, and you found those to be uniquely successful, and how those evolve in different locations or over time as different platforms kind of rise and fall.
Yeah, that's a great question. And the question was about if we've found a specific tactic to be the most effective and if that's changed over time. I wish I had the data scientist on my team to answer this because she's the most familiar with this data, or with this part of the problem, but I would say the channels that we continue to invest in have shown good performance over others. And what we do is we budget accordingly. And honestly, like depending on your business, which mode of marketing is the best which will change. And so I wouldn't say that it's always just the one. It's always a mixture, and then the question is how do you make this mixture the most effective? And that's when measuring the ROI impacts come into account. So you can decide like fractionally, I want to spend more on like putting flyers on the bus stand, and fractionally I want to spend less on doing something else. And so it's always like an evolving mixture, and basically we test model performance to better forecast how to decide this budget mixture in the future. Yeah.
And do you end up having to, like, is that different substantially locality, so like a financial center versus a restaurant heavy district or something?
Yeah, so the question is about if the locality makes a difference. So it definitely does. The problem with online marketing is that the privacy issues really prevent you from getting super granular about this, and so you can make some claims on a state level, like this state is most amenable to using, and now you have also the fact that like California has pretty strict privacy laws when it comes to digital marketing, and so it becomes harder to parse out. So I would say like we use a like all over America approach rather than. And we are trying to do like more local focused efforts of marketing, but these are just a little bit harder because the granularity is missing due to privacy laws. Yeah.
Thanks.
Hi, I wanted to ask about anomaly detection. So, in your payments, when you're trying to detect fraud, how do you go about that? Because you may have information about your client that's using Square, but you don't have maybe a lot of information about who is making the payment to your client. So how do you detect that payment may be fraudulent?
Yeah, so the question is about how to detect if a payment is fraudulent. Is that like when you don't maybe have all the information about the scenario?
Yeah, what kind of feature do you look try to have in order to detect like anomalies that may flag your system?
Yeah. So again, this is another team, so I'm gonna speak more vaguely just because I don't run those models. So firstly, when you have very high, like payments are high volume commodity, and so you initially want to do something rule based, where you filter out like this is just safe. Like I know that this payment is very safe. I'm not even going to try to look at it. And so you filter down your pool, and then the features you probably look at are like, have there been any fraudulent transactions using this specific credit card or at this specific merchant? Do I have some sort of like credit score or something associated with somebody? Like some of these features where you look at previous transaction history to understand if this could be an anomaly, a fraud or not. Yeah.
Thank you.
So I wondering, so I know it's quite a big company, so you UX team. So is there any overlap between your work and the UX team, or you separate it? So like if user UX team, they usually interview user to find the pain point in a journey. Do the data science team take that and change more? How do you cooperate with the UX team?
Yeah, the question is how data scientists collaborate with the UX team in order to make user journeys better. My understanding is that it's it's a collaborative effort. If you're a data scientist and you're trying to understand the customer journey, and you find out that and this has happened at my previous job as well, where that was my job, is to like find out what user journeys are and where in that funnel people are getting stuck or left behind. And so as a data scientist, you would say these are the pain points. And hopefully if you're working on that project, you are talking to some UX people at your company, and that's how it's structured in a reasonable way. And so you bring it to them, and then maybe they bring their findings of what they've found, and then you see if some of their findings from these surveys are actually the cause for you identifying some of those bottlenecks or not. In which case, I think those are higher priority things to solve. You probably prioritize into buckets what the solutions can be. And so it's like, is this easy? Have I heard this from people? Yeah, that's what I should solve first. Or is this where 50% people get stuck and here only 3%? It's unpleasant, but not a lot of people are even going down that path. It's not that important to solve. And so that's it would be a collaborative effort, I believe, and that's how I would go about it. It's trying to see what each team has identified to find the common area of what should be solved first, and then go down from there.
I have another question for small startup. We don't have a UX team. What do we do? Do we do the UX or
So at a small startup and you don't have a UX team, well, I guess my question is who designed the app in the first place? Was it engineers?
I think so.
Yeah, but once you identify where something is not going well, you want to go back to the people who built that portion, that component of your experience, and tell them, look, this is what I found, or some sort of product manager. Do you solve it yourself? If you have the skill sets and if you have the right GitHub permissions, then feel free. But I would try to identify who owns this part of the app, who's maybe the technical owner or the product owner, and then try to talk to them to provide your findings and see what's the path forward from there. I wouldn't take it upon yourself initially to just fix it. I would just be this is what the data has told me. Who can I present this to where it will have the most impact on the company's bottom line? Yeah.
Thank you for sharing all your expertise. I'm kind of interested in your career path, because I'm maybe interested in academia. So I was wondering what parts of your PhD prepared you for this work, what you learned on the job, and do you ever kind of envision yourself going back into computational chemistry, or do you think that this is what you do?
Yeah, so the question is about transitioning from academia and maybe questioning if I want to transition back into academia. I will answer the first part. So what did I find useful? So my PhD was in computational chemistry. The chemistry part maybe not so useful, but the computational part very useful. I was not writing the best code, but I was definitely writing code in my PhD. I was putting it up to GitHub, and I was also just working with tens of gigabytes of molecular data that I had to process and visualize and make plots of and try to understand what's happening, and then use probabilistic techniques to perturb the system and see its behavior in other situations. And so all of that has been super useful. And at the end, my goal was to build a simpler model of a more complicated molecular system. And so that's sort of involves fitting parameters and making sure that your errors are the least. So it was not machine learning per se, but building predictive models and just understanding the power of using something simpler to represent a much more complicated system. So all of that has been super informative. Would I go back to academia? Not at this moment, no. I like the shorter return on your investment in industry. I find that academic projects are years long, and that's too long of a time frame for me to stay really focused and present and motivated, and I want something that finishes in like a quarter or 2 quarters or something like this to see an immediate effect. And also I like having real world impact. I felt like, and this is different for whatever academic program you're doing, but I felt like there were 15 people in the world who really cared about exactly what I was doing, and everyone else was peripherally interested. And now, like a whole company, it's not run on my whims, obviously, but like I make a difference to the bottom line. I help bring in profit, and as capitalistic as that sounds, that seems valuable to me. So yeah, not at this moment.
When you started your PhD, was your intention to go into like maybe like chemistry industry, or was it, or like did you always kind of know that you were going to?
Yeah, when I started my PhD, I thought my father is a professor, so I thought I was going to be a professor. And then after a semester, I was like, well, maybe that life is not for me. But I didn't know what life was for me, so I felt like I spent like 2 or 3 years just sort of like going along and just doing the motions. And then towards the end, honestly, this is when I realized that deadlines help me, is when I needed to graduate in a year. I was like, well, I need to figure out what I actually should be doing, and started talking to different people, doing informational interviews, and realized like data science is a perfect complement to my skills, but not exactly in the same space. So that was another reason why I like industry. There's deadlines that I'm expected to meet, and that keeps me motivated.
Awesome. Thank you for, oh, is it related to, because I have a bunch of questions to go over. Maybe. Oh, sure, go ahead.
Thank you for the talk. I saw one of the slides you mentioned you built some models like binary classification, causal models. So can you elaborate like what kind of models I would like make and showcase that to the interviewer in order to get a position?
Yeah, so the question is about, in one of my slides show a bunch of different types of models. The question is, what kind of models can you build to showcase your skills? I would say it's not necessarily the kind of model, but maybe more about telling a story with the model that you're building. And so I would think more about why did you build this model? Like the skills will come, like you will build different models throughout your career. You will use different technologies and all of that, right? Like I'm just like, use some sort of boosted trees to build a model, and that will get you fairly far as long as you know how to do that. But why are you building it, and what is the purpose after you've built it? I would think much more about those, because I think when I switched over, that was the part that I was missing, is like, what is the business motivation maybe to build this model? Like, how do you tell the full end-to-end journey? How do I trust that you can own all parts of this process? Like, how do I trust that you know where's the data? You went out, you found the data to look at, it was the appropriate data, these were some of the insights that you got from it, and then you decided that building a model was the right decision, you built that, and then with the results, now you have been able to say X or achieve blah or whatever it is, and that shows much more of your skills as a data scientist, is the storytelling with data. So that's what I would try to work on. Yeah.
Thank you. Any more questions regarding the talk? Then I will go over more of the personal questions about Pratima's career journey. I think this can, for our student who wants to relate your experience as a data engineer. Because one question was similar to the previous question that was about your transferring from computational chemistry to data science. By the way, it was a great talk. That it was a great motivator. Our A/B testing course is coming up in the winter intersection. Sometimes students enjoy too much on their winter break and not focusing on the A/B testing. But this shows the value of how much industry cares about A/B testing. So hope that you can focus on the our intersection well. So one question that we have is, how does AI innovation change the data science industry at your workspace right now? I guess it's related to the LLM models and in the near future. And if you were to graduate this year and decide to apply for a machine learning job, what would you do differently because of the industry changes?
Okay, so I'll try to answer the first question, and if I remember, I'll answer the second one, or you can repeat it back to me. So how has AI, and I'm guessing by AI it means large language models, affect data science at my company? We're definitely trying to harvest the power of these large language models and see what they can do, but I don't think they're being applied everywhere. Because it doesn't really make sense, because it's one of these, like, it's a technology and you don't want to find problems that fit the technology, you want to find technology that fits the problem. And so we're using it, but it's not, taking over everything. Not all of our jobs have been replaced by or like not all of our projects have been replaced by now we're all doing large language models. It doesn't make sense when we're trying to figure out what's a fraudulent transaction to say, oh, ChatGPT, is this transaction fraudulent or not? That being said, we are using large language models to make work streams better, because you can tell them the information that already exists at a company to draw from, and then use that to supplement your work, supplement somebody else's work. So that's the sense in which we've started to use it more now, and so it's not directly affected data scientist's job, and I don't believe that it's drastically gonna affect. It's like another one of these technologies that we're searching for where we can apply it to, because the problem naturally demands it. Yeah. And then the second question
Is given these changes, how would you change your job search strategy based on your comments? I guess not everyone requires LLM skill set. Can I assume that
Yeah, I mean, unless you are specifically trying to apply for an NLP job or somewhere where fine-tuning a large language model is required, I would say just do what you're doing. I think there is a lot of hype around it, but when it boils down to, at the end of the day, is what are the things that are solving the problems, and what are the problems that you're interested in solving? What are the technologies that are solving the problems that companies have, and which companies' problems are you interested in solving? And I would try to find that intersection of things and try to learn about those. And if that ends up being large language models or NLP work, then dig deeper into that and go fully into that, immerse yourself in that world. But if that's not what you want to do, then look for companies that aren't necessarily trying to use large language models for everything. I also think that this is a personal opinion, that there is some hype behind it, and just jumping on a fad or a hype and then realizing that this doesn't work as a business model and you cannot get funding anymore is not great. And so this is the risk-averse person in me talking, but I always choose less risky, more stable, less fatty technologies. Yeah.
That makes sense. So there are a bunch of questions, but I will ask a related question since we were talking about the job here. So I guess this is a lot of time our students are asking, how would you define, I guess it's really hard to define, how would you distinguish between machine learning engineer from data engineer or data scientist?
Oh yeah, I think there is definitely distinctions between those job families. If you're working at a small startup and there may not be a UX team, I don't know where that person is.
So engineer?
Then maybe you're doing all three things, and that's fine. But I would say a machine learning engineer is someone who's building machine learning models, and both building them but also deploying them to production, to make sure that they're working in whatever actual use case that you want them to work in. So that's more of a machine learning engineer. A data scientist is somebody who's doing two things, or three things actually, who's maybe supplementing this machine learning engineer with the data that they should use, who's helping them measure, or not helping them, but just like measuring the effects of different things that are happening. Like maybe it's machine learning models, but maybe it's just like normal, two different, like you tested, like the basic A/B test, right? You test out two different colors on your checkout button, like which one is working better, or whatever it is. Like that's one thing. And then just drawing insights from data. And that doesn't necessarily mean making models, but it means like segmenting your data, analyzing different metrics around different segments, trying to understand like what works, what doesn't. That's more of a data scientist role. And then a data engineer, I would say, is the most separate from all the two of these. They are making sure that the data pipelines are correct. Like if someone is clicking a button on your website, how are you making sure that their button click is logged to the correct like SQL database that somebody downstream may or may not use? How do I make sure that the history exists? How do I make sure that everything is flowing through that pipeline in the proper way possible and going into the right data tables? And so that's more of a data engineering job. And like basically as a machine learning engineer, I don't necessarily talk to data engineers. I just use the tables that they've built. They are like, I've used the tables that come from the pipelines that they've built. And if I have questions, I'll ask the data scientist, like, hey, what is in this column? And they will know that. But yeah, that's what a data engineer is.
Awesome.
In my opinion.
I just have a very good question related to this, because you said that data scientists have to like do a lot of data analyst job. And what would be the difference between data scientist and data analyst?
Okay, the question is difference between data scientist and data analyst. That's a good question. I don't know that I have a best answer to this one. I think, like, a very not correct distinction, but maybe the one that exists in my head, is a data scientist uses both Jupyter notebooks and SQL queries, but a data analyst mainly uses SQL queries. If that helps at all, like that's kind of how I think about it. Like probably a data scientist is like partway between the two, and the data analyst is like much more looking at SQL queries, or even like actually and dashboarding much more. So building visualizations, building charts to show stakeholders so that they have easy access to what's happening. And a data scientist is not necessarily building like the prettiest charts, but is building some basic heuristic charts to show like what the data is showing you. Does that help? Yeah, okay.
Then given that there are so many different categories that our students might be interested in fitting in, our students will go on the job market around like February-ish. Then given this is like December 1st, how would you recommend to like start preparing their like technical skill set or even resume? What would stand out as a candidate if you're on the other side of the seat? Then what kind of candidate is company going to be interested in having as a skill set, or what is on their resume?
So I haven't hired candidates, so I don't know that I have the best hiring manager answer. But I would honestly try to understand which, this has helped me a bunch. So understand which part of this whole data life cycle, right? Data engineering, data analyst, data science, machine learning. There's different parts of this. And even with data machine learning, you can be much more modeling, or you can be like a software engineer almost, trying to like make all the infrastructure to deploy machine learning services. I would try to understand what is your interest, and then find the companies that are hiring for that role. Rather than like applying to everything that says data science, like I would try to focus a little bit more. And this will maybe help you create a better narrative when you talk to them, when you send them your resume as well, because like you can show that you're interested you can write the little blurb line on the top of your resume, and you can cater that to whatever that your interest is and what the company's looking for. So that's what I would do. When you're working at a company, it's not just you're working for them, but they're also providing like a place where you spend half your weekdays at, right? Like you're asleep for 8 hours, you're at work for 8 hours, and then you have your life for 8 hours. So like out of the time that you're awake, you're spending half your time at this company. So you want to make sure that what you're doing there is something that you're at least peripherally interested in. You don't want to apply for a job where like none of it interests you, but the job title is correct, because you'll be able to do it for a little bit, but then you're gonna get bored, and you're all smart people here. Like you want to do something that's interesting to you. So I would try to narrow it down first, like where you want to go, and then craft your resume towards that, and show that passion so that the person who's hiring gets excited about the fact that you're interested in this specific thing.
Totally makes sense. The other question that I have is what's more important for prospective like machine learning engineer, broad set of skill sets or a more narrow, in-depth understanding of a subcategory of like machine learning or certain techniques?
Yeah, that's a good question. And I think it depends on what the company does. So when the role I joined, it was much more like broad understanding of machine learning skills, and then on the job you learn the specific domain, and you craft your solutions towards that. But I imagine if it's NLP or like what is it called? Computer vision. Like these specific techniques that require like much more mathematical background in that specific field, and you're interested, you want to work at Cruise or something like this, then I would say then you should dive deeper so that you can show that you have expertise in that specific machine learning category of problems. And so it depends on where you're trying to find a job, that the role can be more of a generalist role. And I know that at big companies, they're actually not even necessarily hiring for a specific team. They're just hiring for like machine learning or like data scientist. And then once you apply, they're like, who is actually looking for somebody? I'll match you with the team. And then, what's the point of being very in-depth in one thing when even in the interview process, they can ask you any question. And so it really depends on what kind of companies you're applying for, whether you should go broad or go deep. Yeah.
Makes sense. Question.
Just like really quickly, what would you consider like a core like tech stack for an ML engineer?
The question is, what is a core tech stack for an ML engineer? Changes with the job, definitely be able to use Python. I would say, and like some sort of change detection system like GitHub, to be able to make sure you can maintain and deploy code. More than this, any sort of like Snowflake or SQL, some sort of SQL database interaction. One of the two, like AWS or GCP, working with either one of those to deploy your solutions, to store your data, to store your models, anything of that. Docker or like any sort of containerization techniques to be able to deploy your model in its unique environment without getting messed up by requirements outside of it. Those are some of the things that come to mind. Yeah. Being able to query data, being able to handle that data and build machine learning models, and then being able to deploy that data to a solution that can handle all of that.
Yeah. Then let's say you initially complete the interview step, and what's your average day look like?
I feel like even when done interviews, I've been asked this question. My average day looks very different depending on what I'm doing, like where I am in the life cycle of a project. So maybe I'm gonna flip it and say, what does my average 3 months look like? And depending on where I am, the day will look like that. And so usually, and I say 3 months because it's a quarter, and that's usually the time period for delivery of a project. And so the start will be, okay, this is the problem that we're trying to solve, how to talk to stakeholders, what do they actually want? Because I'm building a solution, but if I'm building a solution to optimize the completely wrong thing, what's the point? No one's gonna be happy with it. So talk to the stakeholders to understand what they want to optimize for, and also what the limitations are. Like what are things that they just will not accept because it doesn't do X, or it's always predicting Y, or something like this. So understanding the actual business use case around the problem that you're trying to solve, then distilling that into whatever technical specifications. So this is what I propose, and we are a document heavy company, so a lot like writing up your proposed solution, being like, this is what I've identified by talking to these people. I believe that we can build this kind of machine learning model, and we will monitor these metrics as a result. And then it becomes much more technical, like find the data to build that machine learning model, explore that data, do this all in a Jupyter notebook, and maybe through some iterations of data and machine learning models, you identify the best candidate. And then the next step is productionization. So this is where, you clean up that code, you branch off of GitHub, you write it really nicely, and then you deploy your Docker container and test out if it works in a production environment or not. So that's much more like the code technical heavy part of it. And then once you're done with all of this, then you, again, doc heavy, but I think for just general communication, like write this all down in some sort of like presentable format, so that you have a copy of what you've worked on that you can show to other people whenever they're like, what did you do? You can talk about the proposal that you wrote, and then talk to them about the technical solution that you came up with that matches with the proposal that you wrote. And then figure out how you're gonna deploy it. Is it an A/B test? Is it gonna fully replace a system? Is it the first thing that you're doing, and then you wanna like measure how this works in the real world? And then deploy and measure, and then iterate in the next quarter on that or on something else. So this is what my projects look like, and depending on where I am, the day will be full of that thing. I also prefer to maybe work on like a couple things so that I have a break, like I can do something else when I'm getting bored or tired or frustrated with something. So I prefer like switching between two different things, but that's just me. There are certain people who are like, leave me alone, I'm in my cave and I just want to like dig deep into this problem for like 3 weeks, and that's fine. And you have to figure out what kind of person you are, and that's how you communicate with your team and your manager is your working style, and hopefully you find a team that's supportive of that, and that's how you work. So you ask for what you need, and then you try to do that. But yeah.
That sounds really exciting. Yeah.
Just quickly going off that question, you compare to previous roles as data analyst, data scientist, just work-life balance. How's machine learning engineering compared to previous roles? Is it a lot tougher? Or
Yeah, so the question is about work-life balance as a data analyst versus a machine learning engineer. My work-life balance was worse as a data analyst / scientist because it was a startup and things were always like breaking, or just like the customer asked us to get this tomorrow, and they asked us yesterday, can you get this report to us right now? Can you like figure out this table right now? So it was a lot more hectic. It depends. So it's better as a machine learning engineer, personally, for me, for the work that I do. It does depend on what kind of team you're on and what kind of project you're working on. Like I know, like if you are working on something that's fraud detection or something like this, like maybe your on-calls are a lot more stressful. I've had friends who've worked at different companies where depending on the team that they're at, like when they're on call, they have to carry their laptop everywhere or they cannot leave their houses. And for that week, your work-life balance is not great, right? But then you bounce back. And so I think machine learning engineer is generally more straightforward because there are less ad hoc requests and it's much more structured. Like I'm just building a machine learning solution to this. Like you cannot ask me to give you something yesterday. Like it just doesn't happen. The most that can happen is someone says like, we need to have a solution by X date and then you have a deadline and sometimes you have to work extra hard. But otherwise the project lifecycle is fairly defined and so it's a little more, it's a little less ad hoc.
Sounds like we have work-life balance now. So the other question is that machine learning, data science area evolves so quickly and so competitive. How do you keep up with all those new technology or algorithms? That's, I guess, also relates to the work-life balance, and can you stay up late to like read articles or not watching any TV? I had online speakers and they're like, how do you keep up with it? I don't have TV at home. Like, I don't have Netflix or anything else. So I want to hear what your strategy is.
I'm not how this person enjoys their life. I definitely have Netflix and TV at home. I would say this is probably an improvement area for me too, is to keep more in touch with like the latest technology. But again, it depends on the project that you're working on. If you're doing something like research heavy at like Meta or Google, then that's your role. You're required to read these papers and learn what's happening. If your role is much more like just optimize this campaign, which is what I'm doing now, then it's like when you're ideating, then you read papers, but otherwise you're just trying to like make sure that the work gets done. But there's obviously, like depending on the company, there's time for learning and development. There's time to do, this is like, I used my somewhat learning and development time to volunteer and work with Diane, that's how we met. Did it help me learn like the latest cutting edge technologies? No, but I also recognize that I'm not the kind of person who needs to like read all the latest papers, and so that's fine with me. I've asked coworkers what they do, and a strange answer, which I did not choose to do because I know myself, is to use a tool like X, or formerly Twitter, because there are machine learning researchers who will post things there, and this is like a bite-sized way of understanding what's happening and like maybe clicking into reading a paper. That's an advice someone gave me. So if you're like, this person writes really cool stuff and they're posting online somewhere, then follow them and see and read those papers. I wish I was better at it. So whoever asked this question touched one of my weaker spots. I prefer Netflix over reading a paper. Yeah, so the question is, once you've done whatever you achieved to do as a machine learning engineer, like what do you do next? And that's a great question. I think it's a combination of you make sure that what you learn, data gets stale, and so you make sure that whatever you put into production continues to work and is not failing and is not breaking. That's one part of it. The second part of it is maybe your team has like a bunch of projects that need to be done, so you just move on to the next one in the pile. And then the third option is you try to talk to your business stakeholders who you maybe solved a problem for. And in the process, you identified, oh, this is like a very automated thing that you guys are doing manually that maybe machine learning could help with. You proactively identify where you could apply machine learning solutions to. So depending on honestly where you are in your career and what the team is like, you're required to do, when you start, you're probably just building a model and making sure that it works. Like it's a pretty defined project. Maybe once you grow a little bit, then you're like, oh, there's a bunch of other things that my team is working on. Let me pick up another thing that's very different from what I do and try to learn it and try to tackle it. And then once you grow even more, you're actively trying to find what are the problems out there that I could apply my expertise to. So it evolves as you grow in your career.
You know, because our time is over, but let me ask one question that someone asked here. In your experience, how much time do you spend setting up the roadmap for experimentation? You mentioned about A/B testing in data science project. And what are the key considerations that can be valuable in this stage for, I guess, designing your experimentation?
Yeah. So budget. Like knowing how much budget you have for experimentation decides how you even begin to set it up. But then for us, especially on the online channels, like these are governed by different platforms. And so we can actually only run A/B tests for a certain amount of time. So we're sort of like constrained externally. So sometimes it depends on what you're testing. You may not even have that much of a say in it. But usually you try to do some sort of power analysis to identify what is the targets that you need to achieve in your A/B tests. And then that helps you decide to set the significance level of your test before you even begin. And so you're not biasing yourself. Then you set the test up and you make sure that it runs till you are able to achieve that sample size. Or if you're not able to achieve it, then you use some sort of like confidence intervals or something else to quantify your results. So it depends on the situation, but I would work, if you're a machine learning engineer or a data, like depending on what you're doing, I would work with the appropriate people to identify what is the budget available to me, what is the traffic available to me for this A/B test, how long can I run it for, what are the effects that we're waiting to see, and am I trying to look for like an immediate metric, or is it a much more, like profit generation, right? Which is much different than just conversion display. And so converting, like I may see an ad and I may convert tomorrow, but I have no idea how much profit I generated. And so if I want to monitor both metrics, like I need to wait for long enough and tag these people for long enough to make sure that I'm looking at all the metrics that I'm trying to optimize. So yeah, budget, time, statistical significance, metrics, and then a tagging. Tagging is very important. You need to know who was A and who was B in your tests. And this is, again, like sometimes it just is hard and you don't know, and then you finish the test and you're like, wow, I didn't even know who was in the control because I forgot to log in. So yeah, make sure you don't do that.
That's amazing. It was really insightful for hearing about Pratima's work and also her personal journey as well. So let's give a round of applause.
Thanks, everyone. It was a pleasure to chat with you, and I'll stick around for a few minutes if you have any questions, but thank you for listening to me.